Okay, so this is our paper 2 from 2025 mock from DEB. Question 5 is a construction. It gives me the length of A to B, A to C, and then the angle at A. Okay, the angle made from C to A to B. Now, I'm not going to do the construction out properly because you won't be able to see the geometry tools that I'm using. But remember, before you start, you're always going to just do a quick sketch of a triangle or whatever it is that they're asking you to draw. Okay, in this one, A is on the bottom left. Okay, or if you have to sketch this upside down, up on the top left. Okay, but just have that line in there as they've given it to you. Okay, now the triangle is going to be A, B, C. Okay, and I'm going to just fill in the information that they've given me there into my sketch so that I have an idea of what I'm drawing. So from A to B is 9 centimeters. Okay, I'm using a pencil because it's a diagram. A to C length is 7 centimeters, and then I have the angle from C to A to B is 60 degrees. Okay, so that's what I need to sketch. And now I need to actually construct the actual triangle. Okay, you have a full playlist of how to construct these, and this is one of the easiest constructions you can get. The first thing you're going to do is draw a line that is 9 centimeters using your ruler. Okay, then set your compass needle to the end point of that and stretch the pencil out to the other end. Okay, so that you have an arc there. And then without moving the distance between the two legs of the compass, you're going to lift the needle from this point here over to here and then draw that arc out again. Okay, so now I know where the point B is because it was 9 centimeters away from A. Okay, which this is not to scale. I'm just giving you a quick example of how you would do it. Okay, then we would get our protractor to measure our angle at A. Okay, so there's a little sketch of my protractor. You're not doing that sketch. Okay, but you are looking for 60 degrees. So remember, this is the 0 degree mark. And then you're looking at the lines here that are getting bigger as you go. Okay, you don't want to start at 180 because this is 0 and you're working your way upwards. If the line went this way, then you're following 0 from this side of the scale. Okay, but the line goes out this way, so this is the 0 we're starting at. Okay, and we follow it up. It's increasing, the angle's getting bigger, bigger, bigger until it gets to about 60. Okay, so I'm going to say 60 degrees about there, and I draw my point there. Okay, now I'm going to rub all that out so that you can see the construction lines that you're actually meant to have in this. Okay, which is, where's my pencil? Okay, so the protractor is here. Okay, and you follow the line up to 60 and you draw your dot. Okay, then get your ruler. Okay, the ruler is being weird here. There we go. Okay, and place it so that you can draw your line through from A through the point. Okay, I'm just not going to use it. But you go from A through that point there. Okay, extend it out past it. And then you need this line to be 7 centimeters. So again, just over to the side, draw your line of 7 centimeters. That was too long in comparison to the 9 centimeter one, I'd say. Is that going to go to an arrow again? There we go. Okay, and again, set your compass, okay, because that's 7 centimeters. So the needle at the end, and set your compass to that length. And then move over to where your image is, or your construction is, and draw that arc. Okay, one nice clean arc. Okay, and where that intersects is my point C. Okay, last thing I'm going to do then, because I have the second points of the triangle, is get my ruler and connect up B with C. Okay, and now that's the construction complete. I'm just going to quickly mark in the information that they'd asked me to construct the triangle with. So the 9 centimeters, the 7 centimeters, and the 60 degrees. Okay, so this is what your page should look like, but more accurate measurements in the actual construction. Okay, but you should have a sketch and you should have your lines that you've used to measure those distances. You should have them down as well. So then I have to measure the angle from A to B to C. Okay, so from A to B to C. So if I look at that angle, that is this angle here. Okay, I have to measure that. Okay, if you had it accurately drawn, that angle should be somewhere around 50 degrees. They were accepting anything in your construction between 48 degrees and 52 degrees. Okay, so 50 degrees, but they allowed for a 2-degree error. So anything between 48 or 52 was given the marks there. Anything after that is not getting the marks. Okay, now explain why you would expect this angle to be the smallest in the triangle ABC. Okay, they are looking for the fact there that when we have a triangle, remember we looked at this when we looked at the right angle triangle, and we looked at the fact that the hypotenuse was always the longest side. Okay, this is coming from the same idea. So this is my right angle triangle, and it's the largest side or longest side because it's opposite the longest angle. We know if we have in a triangle an angle of 90 degrees, that has to be the largest triangle, because the other ones, the very max that another one could be will be 89.9999999, and then another one that's like 0.00001 degree. Okay, but the largest side or the longest side has to be opposite that longest angle. So if we have any triangle, it doesn't have to be a right angle triangle. Okay, in any single triangle, when you have a very clear largest angle or very clear largest side, they are going to be opposite each other. Okay, so here is my largest angle in that you can see it just even from the sketch, and it is opposite my largest side. Okay, you can see then if I'm marking another one, the smallest angle is definitely here. Okay, and again you can even just see in the sketch that that is the smallest side. Okay, so largest angle opposite largest side, smallest angle opposite smallest side, and middle angle opposite middle side. Okay, so we would have discussed that in our trigonometry stuff now. Okay, so there we go. So my middle angle here opposite my middle sized side. Okay, so it says, explain why you would expect this angle to be the smallest angle in the triangle. Okay, it's opposite the smallest side. Okay, so that's what they were looking for there. Okay, so this angle is opposite the smallest side. Okay. Now, oops, don't know what happened there. Okay, right. So this construction up here was for 10 marks. And then these 2 points together, measuring the angle from it and just making the connection between smallest angle and smallest side, those together gave you 5 marks. Okay. Now moving on to part B. It says a triangle O or S. Now this one, it just has a sketch of the diagram in it, but you guys had the actual one. So the triangle O or S is the image of the triangle OPQ under an enlargement. Okay, so straight away, if they're under an enlargement, okay, what that's telling us is that it's the same angles. Okay, under an enlargement just means the sides get bigger, the angles stay the same. We are looking at similar triangles there. Okay, so similar triangles, remember it's the same triangle, but one's bigger than the other or one's smaller than the other. So we, as soon as they've told us that, we are looking at similar triangles. Okay, all the angles in one are all the same angles as the one in the other. Okay, so it says O or S is a right angle triangle, and they have that filled in for us. So O to P is 6. P to R is 9 centimeters, or to S is 12 centimeters, and then it tells us where the right angle is. Okay, so first thing says, show that the scale factor of the enlargement K is 2.5. Okay, so remember what we were looking at when we're looking at scale factors. Okay, scale factor, we always use that letter K. Okay, and we have to show that it's 2.5. Now, when it says show, we have to pretend we're not given the answer. Okay, pretend you're not given the fact that it's 2.5 and treat this as if they said find the scale factor of the enlargement. Okay, now to do that, we have to look at the two triangle sizes that we have on the corresponding sides. So we have this triangle here, I'll do this in green. We have this triangle here that has a side length 6, and then we have the bigger triangle here with its corresponding side. Now remember, you're not just looking at the extension for that. Okay, so they gave me a distance, but that's not the bottom distance of that big triangle. The bottom distance is the 6 and 9 together, so it's 15. Okay, now that part is the part that caught a lot of people. Okay, so when we're looking at the scale factor, we can just say, so it's the bigger side over the smaller side, or the smaller side over the bigger side, depending on which way they've asked for it. Okay, so here, when they're talking about the image of the triangle, okay, so it's the new one, the bigger one is the image here. Okay, so actually really what I should say there is the image side, size of the side of the image. So, size of image length over the size of the original length. Okay, now the original, what do we call that? We call it the object. So size of object length. Okay, now they have to be corresponding sides, which in this they are. Okay, they're both the bottom sides. So if I want to go and write that as a fraction, the size of the image, the enlarged one, is 15. And the size of the smaller one, the original, is 6. Okay, so I'm looking at 15 over 6. When I type that into my calculator, it's going to give me 2.5. Okay, 2.5. That just made it more difficult to read. Right, so that's it shown. Okay, then it says using the theorem of Pythagoras. That was really nice of them to tell you. Okay, find the distance from O to S. Okay, so this largest distance here, and hence show that the area of the triangle O or S is 54 centimeters squared. So using the theorem of Pythagoras, so straight away there I'm just going to get my marks for writing down the theorem of Pythagoras. So it's A squared plus B squared is equal to C squared. And we know the important part of that is that C is the hypotenuse length, and then A and B are the other two lengths. Okay, now if they hadn't told us to use the theorem of Pythagoras and they asked us to find the distance from O to S, we still could absolutely see that we would use the theorem of Pythagoras, because I have a right angle triangle. So straight away it's either Pythagoras or SOHCAHTOA. And I'm trying to find a length, but I have another length and no sign of any angles. Okay, so remember, right angle triangle and you're working with 3 lengths, including your unknown, means that we are using the theorem of Pythagoras. Okay, now, straight away, we want to write in where C is, it's my hypotenuse. Okay, so C is going to be my side 15. That is the hypotenuse. Okay, opposite the right angle. And then the other two sides are just A and B. Okay, so we've written out the theorem of Pythagoras. Let's get our marks for having it subbed in correctly. Okay, so A, I have nothing to sub in for A, so I can leave it as is, or I can write something like X or something like that, to, like, if I wanted to change the letter, you can. Okay, then for B, I have 12. So 12 squared equals And then just noticing again, our hypotenuse is the longest side we have. So I am expecting, because my hypotenuse here is 15, I'm expecting my answer to be less than 15. Okay, because 15 has to be the largest side here. Okay, so if we go through this, okay, so it's a squared plus 144 plus 225, or equals 225. Okay, so once we've gotten our marks for subbing it in, then we just need to try and find what a is. Okay, so fully simplify both sides. So a squared plus. Okay, so I'm going to fully simplify both sides before I start rearranging. So 12 squared, I'm going to get 144. And then I'll get equals, and then 15 squared is 225. Okay, now that I have both sides fully simplified, I have to say, how can I get a on a side by itself? When I'm looking at this, okay, when I'm looking at getting something on a side by itself or moving things across the equals, the order I do that in is backwards BIMDAS. Okay, so look at this left-hand side and ask yourself, well, what is in the way of getting a on a side by itself? There is the squared part, which is an index a, and there is the 144, which is adding. Okay, so I have two things I'm going to get rid of. I need to get rid of what's adding first, because that's what comes first in SABMIP. Okay, so to get rid of 144 that's adding, I do the opposite of the adding. So I'm going to subtract 144. Okay, and then I'm going to get that a squared, I'll write it over here, a squared is 225 minus 144, so 81. And then I have to ask myself, okay, how do I get rid of the squared? Okay, so to get rid of something being the squared acting on the a, I have to square root. Okay, so that we get a is the square root of 81, which is 9. So a is 9. Now, don't forget that that is one of the things they asked, so there's probably a significant amount of marks going for this a equals 9. So make sure your answer is written clearly and includes its units. Okay, so we were looking in centimetres and areas and centimetres squared and so on. Okay, so don't forget your units there, it's 9 centimetres. Okay, so they ask for the length of OS here, so I'll just write it down again. It's 9 centimetres. Okay, so that's the first part done. And then they say, and hence show that the area of the triangle is 54 centimetres squared. So remember, them telling you that is them being nice because you have confidence in your answer when you get it. But you have to pretend you weren't given it. Okay, when they say show that the area of the triangle is blah, 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 you have to pretend that you weren't given that and you have to read it as just find the area. And then when you get 54, you're happy with your answer. Okay, so for the area of a triangle, now if you're really, really stuck, obviously, and you come back to it at the end, and you're still really, really stuck, okay, do just, write what you can. Okay, but really, guys, here, when you're first doing the work, really, really try and do it just finding the area of the triangle and assuming you weren't given the answer. Okay, now, when I go through this, and don't use red pen, okay, the area of a triangle, I'm going to start by writing my formula. It's half AH. That's what it looks like in the log tables, okay, or you might remember it if you learnt it off as A equals half times the base times the perpendicular height. Now, that is what AH is when you look in the log tables at the picture. Okay, A is just the side that has a perpendicular height on it. Okay, so it's the same thing as what we have here. So when we're using this formula, guys, remember we have to choose the base as the side that has a perpendicular height. Okay, so here, where have I been given a perpendicular height? Well, there is my perpendicular, that right angle there. Okay, that is where my perpendicular is. So I'm going to use those sides as my base and perpendicular height. okay? You're kind of hinted towards that anyway because they've told you, and hence, which means you have to use the length that we have here from O to S, okay? You have to do it. It's not hence or otherwise. You have to use the fact that this distance here is 9 centimetres, okay? And that side has a perpendicular height here of 12 centimetres. So those are the two sides I'm going to be using, the 9 and 12, okay? So I'm going to go and I'm going to sub them in to this formula. So it's 1/2 by 9 by 12, okay? And then when we type that into our calculator, it gives us 54. Okay, don't forget your units. It's area, and we were in centimetres, so it's centimetres squared. Okay, now the units, even when you go back and reread the question, you see there that the units were there. Okay, so that's it done. Then it says, hence work out the area in centimetres squared of the smaller triangle, the original triangle. Okay, so remember how we use our scale factor? The scale factor when we're looking at length is you just multiply or divide by the scale factor. Okay, here it's area that we're looking at, okay, centimetres squared. So we put a lot of emphasis on that squared part when we were looking at scale factors in class. Okay, when the units are squared, that means the scale factor also has to be a squared scale factor. Okay, so my scale factor from earlier on, even if I wasn't able to do the part 1 where I had to find the scale factor, they actually told me that it was 2.5. Okay, so now, because it's area, what I'm going to be using is k squared. Okay, so I'm going to be using 2.5 squared. Okay, now, just look at the lengths. If I was going from the bigger length here, 15, to the smaller length, 6, I would have been dividing by 2.5. Okay, 15 divided by 2.5 gives me 6. So going from the larger triangle to the smaller triangle, I'm going to be dividing with the scale factor. Okay, so that I'm expecting an answer smaller than 54 centimetres squared. Okay, so my original area was 54. Centimetres squared, okay? And now I'm going to be dividing. So this is area of the small triangle. So remember, my subscripts are just labels. Okay, so it's 54 centimetres because that's the area of the larger one. And then I have to divide that, not just by the scale factor. Okay, if it was a length, then it would just be by my scale factor. Okay. Okay, but it's not just a length. It's an area. So look at my units. Okay, it was centimetres squared, so it's being divided by k squared. Okay, so I will just go onto this line here. Okay, so it's 2.5 squared that's dividing here. Okay, so I have 54 divided by 2.5 squared. Okay, so 6.25 there is what's going to be dividing. But we can just type it all into our calculator and get 8.86. Sorry, 8.64. Okay, and it's still the exact same units, centimetres squared.
Class, but could all second years come down to